Hi everyone. Today we want to measure the VI characteristic of diode via LabVIEW. We want to build circuit with a diode, and then we will automate the process of measuring the VI with LabVIEW. So first of all, we need to build a circuit. It includes, as you can see, 100 ohm resistor, the diode. The circuit is very simple. So as you can see, these two are the positive and the negative, which they are connected to power supply. These two, this is negative and this is positive, and as you can see, they are coming from power supply. Here is the power supply. As you can see, the channel 1 of power supply, the positive, and this is the negative. The 100 ohm resistor is in series with the diode. Then we measure the VI, the voltage and current, the voltage across the diode and the current passed through the diode with multimeter. So then we connect this positive cord to the positive of voltmeter, and this is to negative of voltmeter, and this cord, this is common ground with the power supply, and this is connected to a multimeter. This one again, this one is the voltmeter, this is the ground, and this one is the current meter. So now we built a VI, and this VI through PC, through LabVIEW, will control the power supply and current meter and voltmeter, and it's gonna measure for us the VI characteristic of diode, as you can see here in the monitor. So in the next step, I will teach you how to build a VI, such a VI, so you can control the multimeter and the power supply and measure the VI characteristic of this circuit. So again, this is our circuit. This is how we build it. Very straightforward, very simple. This is the 100 ohms resistor in series with diode. This is the positive power supply of diode. This is the negative power supply. This is the positive. This positive goes to voltmeter of our multimeter. This goes to ground, and this goes to current meter. The next step is just how to build the VI, which I will introduce you in the next few minutes. Stay tuned, I will come back. Hello everyone again. Now we want to build the VI of our experiment, the experiment of measuring the voltage current characteristic of a diode. So for doing so, first of all, you need, as you can see here, you need to build your front panel. For doing so, I will just focus on main component that you need to have here. First component that you need to have is the field to assigning the power supply and multimeter. This comes from this step. You can right click, and within the search you can search for VI. As you can see, just when you type VI here, you will have VI resources name. So you can, if you select the first one, you come up with VISA resource. So if I drag this and drop it here, now I can change the label and make it as power supply, as you see here, and if I do another one, drag and drop another one, I can have another field for multimeter. So if I close this window and I open this drag drop, if I and open this, you can see I have two options. First option is for, as you can see, DM here is for multimeter, and the DP is for power supply. Because we already connect our devices, power supply and multimeter, to computer, and we installed the driver for LabVIEW, then LabVIEW can recognize that these two devices are connected to LabVIEW, so you can pick one of them. So the first one is multimeter, second one for power supply. So now, after this, you need to select them and get rid of them. So you have two main components that you need, and then you need a chart. So as you can see, you can drag and drop XY chart, XY graph from your XY, from your controls, and this is the same as this. You can just change the labels and it's going to be work for you. Also, beside that, I pick up for you another sub-VI that I will show it to you when I'm building the back front, the VI, the programming part. So if I want to go that which I will show it to you in when I'm building the block diagram. So as you can see here, we end with building the front panel. Then for building the block diagram, we go to block diagram. Then as you can see here, when we want to building the block diagram, we need to here we need to automate somehow. We want to automate our VI, our process of measuring this VI characteristic of diode. So then we need, in this block diagram, we need to build this structure, this for loop structure. So then we want to, as you can see here in block diagram, we have multimeter, we have power supply, and in power supply we want to set the power supply at some ranges. So by changing the voltage of our power supply, we measuring the current and the voltage drop across the diode, and the current pass through the diode. So as you can see here we initialize the power supply, we configure the power supply, and we configure the power limit. All these options are available from this menu. So if you go to search, as you can see here, if you go to instrument IO and measurement IO, if you go to instrument IO, instrument Visa, you can see for your power supply you have Rigol DP here. As you can see, initializing and configuring current limit, configure output, and all this configure over voltage output, and all this stuff are available for you. So then bring this block diagram here, this one here, and also you can doing so by multimeter. So when we want to set the multimeter to what it's supposed to measure, first of all you set the power supply. As you can see here, I start from 0 volt, and in each step size I increase the voltage by 0.05 volt, and I go up to 30 times. I do this thing 30 times, which means I will go up to 1.5 volt. So I initialize the multimeter, I configure the measurement of the VI, then I read the single point from multimeter, which is the voltage. I pass it through graph as a chart, this sub VI that I already provide you under the folder of this experiment. Then I configure again, I come to my multimeter. This time I measure the current that passed through the diode, and I read the data, single point data. I multiply by -1 because the current, if I want to use the device multimeter as current meter and multimeter at the same time, I should have common ground, and for that reason I forced to do it the current inversely, measure the current inversely. So to get rid of that inverse effect, I multiply the current by -1 and pass it through the chart, and the chart will plot for me the VI characteristic of the diode. It's quite simple, very straightforward. Also, in this case, this is the special case that we work with in this experiment. We want to load the pre-configured setting of our power supply and multimeter from one file. So for doing so, we need to download this. So we need to do it somehow. When we run the code, it asks us about where is the presetting file, the presetting, the settings of our devices, multimeter and power supply, so we can pass these settings through this arrays and this chunks, so we don't have to set our device every time. This is just for this experiment, so don't worry about it. In next experiments you will not have such a things. So now our block diagram is ready based on this connections. Our front panel is ready based on this. If I run the code, it asks me about the path of settings. If I provide the path, it's gonna run the code automatically, and it's end up to plots for me this VI characteristic, as you can see here, after go through this theory iteration, increasing the voltage 0.05 each time, and measuring the voltage across the diode and current pass through the diode, plot the points, and I will have this VI characteristic of diode with, and automating the whole process with LabVIEW. Thank you so much for watching this video, and see you in next experiment.